Welcome to Vivegam V+. In the last video, we saw the molarity and molality concept. Today, now we are going to see the solubility concept in the lesson solution. Okay, first, there are two categories in the solubility. The first category is the solubility of solid in liquid, and second category is solubility of gas in the liquid. So, in the solubility of solid in the liquid, the first point we have to discuss is like dissolve like. What is meant by like dissolve like? We should know. Like dissolve like is nothing but, for example, I am going to prepare a solution, that is sodium chloride solution I am going to prepare. For that I need two things. One is a sodium chloride solute, another one is solvent. Just let us consider it is a water. Okay, so in water there are two things. Water can be dissociated into H plus and OH minus ion. Therefore, this is called as polar solvent. What is meant by polar solvent? A solvent which can be dissociated into its corresponding ions, that is H plus and OH minus. For example, hydrochloric acid, it can be dissociated into H plus and Cl minus ion. So, it is a polar in nature. In the same manner, sodium chloride can be dissociated into Na plus and Cl minus. So, it is a polar solute. Like dissolves like means a polar solute can be dissolved in polar solvent. That is the meaning. Okay. Then, for example, a number of non-polar solvents are also there. What are they? For example, we can say benzene, toluene, carbon tetrachloride, carbon disulfide. Okay, these are all called as non-polar solvents. So, what is meant by non-polar solvent? These type of solvents cannot be dissociated into its corresponding ions. That is, benzene cannot be dissociated into positive ion and negative ion. So, if you want to dissolve sodium chloride in benzene, it is impossible. Why? Sodium chloride is a polar solute and benzene is the non-polar solvent. A polar solute cannot be dissolved in the non-polar solvent, but at the same time benzene and carbon tetrachloride can be mixed. Why? Benzene is a non-polar solvent, carbon tetrachloride is also a non-polar solvent, so they will mix with each other. This is the meaning for like dissolve like. Okay, then next, saturated, unsaturated. I think that it is a well-known fact for you. What is meant by saturated solution? In a solution, no more solute can be dissolved. That is called as saturated solution. And unsaturated solution means more solute can be dissolved. For example, we can say 36 gram of sodium chloride can be dissolved in 100 gram of water. That is called as saturated solution. That is, after 36 gram, no more sodium chloride can be dissolved in the solvent, that is water. So, it is called a saturated solution. But you have dissolved only 15 gram or 16 gram of sodium chloride in 100 gram of water. So, you can dissolve more 20 gram, because 16 gram you have dissolved, more 20 gram, again 20 gram of sodium chloride you can dissolve. That is why it is called as unsaturated solution. Then third one, effect of temperature. What is the effect of temperature on the solubility of solid in liquid? Effect of temperature, it depends upon the endothermic reaction or exothermic reaction. Effect of temperature plays vital role depending upon the endothermic reaction or exothermic reaction. Okay, and effect of pressure, it has no significant effect on solubility of solid in the liquid. Okay, have you understood? Okay. Now we are going to see the second category, that is solubility of gas in the liquid. In this solubility of gas in the liquid, it is somewhat different from the previous one. That is, one container is there. In the container, I have taken one solution. On the top of the solution, some gas is filled and a piston arrangement is also there. Okay. In the second container, see the difference between these two containers. In the second container, the piston is at the lower part. That is, we have applied some external pressure from here. So, the gap is there. Here up to this the gas particles are there. Here after giving the pressure, the gas particles, they are reduced, the region is reduced. Okay, so what is the difference between these two things? What is the difference between? Now, solubility is directly proportional to the partial pressure of the gas. First condition. What is solubility? If you increase the pressure on the surface of the liquid, the solubility will increase. That is, partial pressure increases, solubility increases. And second one, solubility is directly proportional to mole fraction. We know that solubility and mole fractions are related with each other. So what is meant by mole fraction increasing here means more and more gas will be dissolved in this case. In the second container, more and more gas will be dissolved because of the excess pressure we are applying from the top surface. Okay, so these two things, solubility is directly proportional to partial pressure, and again solubility is directly proportional to mole fraction. It is d theta we discussed in the previous videos also. So one scientist, he gave one important relationship that partial pressure is directly proportional to mole fraction. See, solubility, partial pressure, solubility, mole fraction. So partial pressure and mole fraction can be related. This is given by the Henry's law. Henry in the name of the scientist. So partial pressure is directly proportional to mole fraction means to remove this proportional symbol, we are putting one constant kH. This kH is nothing but K, Henry's constant. kH is nothing but Henry constant, and kH is equal to partial pressure divided by mole fraction. So from this we can conclude that partial pressure of the gas increases, solubility decreases. See, they are inversely proportional. kH and mole fraction, they are inversely proportional. So if you increase the kH value, mole fraction will automatically decrease. And partial pressure and Henry's constant, they are directly proportional, no problem in it. So see, kH is increasing, solubility is decreasing, and solubility and mole fraction, they are related. Automatically mole fraction will decrease because solubility is decreasing when this is the condition. As the temperature increases, these are all the things happen. Okay, now partial pressure versus mole fraction curve, this can be drawn or this can be plotted in the graph. So if you plot partial pressure and mole fraction, you are getting a straight line graph. In this straight line graph, kH is nothing but the slope of the straight line graph. Okay, for example, the kH value for different gases at different temperatures are varying. See, oxygen at 293, kH value is 34.86 kilobar. The same gas, oxygen, at 303 Kelvin, kH is equal to 46.82 kilobar. Okay, so oxygen is the same one, but temperature is varying. Temperature is different. So temperature is different. As the temperature increases, kH value also increases. See the relation, kH increases, temperature increases. Temperature increases, kH increases. And when kH is increasing, solubility and mole fraction, they are coming down, because in this relation, Henry's constant, kH and partial mole fraction, they are inversely proportional to each other. That is the reason. Okay, I hope that you have understood the concept. In the next video, we will discuss about the problem in the numerical section. Okay, thank you very much.